when it comes to estimating, it's much easier if you know your multiplications or your times tables. And the opposite to times tables, or the inverse operation, is division. Handy to know those. So in this case, I'm picking you know your times tables, because if you do, you'd be fine with this. We're just using the inverse operation, which is division. Some teachers will say 45 divided by 9, or another teacher might say, how many times can 9 fit into 45? Does it fit evenly, which means there's nothing left over? In this case, I know my times table, so I know 45 divided by 9 is 5. Maybe we'll make it purple, 5. Because we're dealing with tens and ones. So 9 times 5 is 45. The next one looks exactly the same, except we're dealing with hundreds in the place value of hundreds. If I cover up that 0, the question now looks exactly the same as above. In which case I can just put the same. And how many zeros did I have there? 1. So then I put the 0 on the end, which now makes this answer 50, because I'm dealing with hundreds. So every time your place value is increasing, then we have to put a 0 on the end because we're dealing with hundreds. What about if I'm dealing with thousands? So if I cover up, how many zeros do I have? 2. If I cover up those 2 zeros, it still says 45 divided by 9, or how many times can 9 fit into 45? Sometimes you want to get as close to it as possible without going over, if there's some bits left over. Again, put 5, and there's 2 zeros, because I'm dealing with thousands. So 5 times 9 is 45, which must clearly make 50 times 9, 450, and 500 times 9, 4,500. There's another example here, using that same style. What would you do here? 32 divided by 8, or 8. How many times can 8 fit into 32? Times tables come in handy, and division would be 4. So we have now 320 divided by 8. Cover up that 0. Put the same result, which is 4. It's 1 0. Pop it on the end because we're dealing with hundreds, not just the tens, we're dealing with hundreds. Next one says 3,200 divided by 8. Same deal. Cover up the 2 zeros. I know 32 divided by 8 is 4. Therefore, 3,200 divided by 8 must be 400. Because I'm dealing with thousands. We know when it's these 2 digits, the answer is going to be 4. 3 digits is going to give me 2-digit answer. 4 digits will give me a 3-digit answer. So using that, what about if we had 5,403 divided by 9. Same as this one. This is where, again, my multiplication comes in handy. If you don't know it, you're going to find it hard. So learn it. I'm going to have to estimate now. I know my 9 times tables. So I know, I'll put this over the side. 9 times 1, 9. 9 times 2, 18. 9 times 3, 27. And I can see a pattern happening here. The tens column, 0, 1, 2, 3. I can actually predict what's going to happen next. It's going to be something 4. the ones column, 9, 8, 7, 6, they're going down in ones, and you'll find that these two digits will always add up to 9. So for example, if I put 9 times 6 equals 53, double check, 5 plus 3 equals 8, so this answer has to be wrong. It always adds up to 9, which must mean this must be 4. So I'm going to use this knowledge of that multiplication of the 9 times table to help me answer this one. So here I have the ones, tens, hundreds, thousands. So if I cover up those two digits here, 9 can fit into 54, how many times? 6. And how many digits did I cover up? 1, 2. Now if that was a 0, that would be the exact answer. But because there's 3 here, I know 9 cannot fit into 3. So there's going to be some bits left over. But when you estimate, you don't want to be perfect. So that there would be a pretty good estimate. Because I know 9 times 6, if I do the other way, is 54, which must mean 9 times 60. Cover up that 0, still the same. Put that 1 0 on the end. So 9 times 600. Cover up the 2 zeros. 9 times 6. Put the zeros on the end. Which means it's a pretty good estimate. So that's the way you want to be doing it. Estimate. Okay? So let's try one more. 27, 43. Okay, and I'm going to divide that by 5. Okay, so straight away we're dealing with thousands. So I might just cover up these last two digits just for the time being. Roughly, my 5 times table, I might think of 5, 10, 15, 20, 25, 30. 27 is below 30. So 5 times 6 will give me 30. 5 times 5 will give me 25. So my answer is going to start with a 5. Remember, we're estimating. It's not going to be perfect, not close enough. And so I could do 5 times 5 is 25. But because I'm really sort of dealing with more than just the ones, we'll come back to that in a moment. And now I'm looking at, I've got this 43 here. How many times would that roughly fit into there? 8 times 5 is 40, 9 times 5 is 45. So this is what some people do. I put it into 27, and I divide it into 43, so 8. This wouldn't be a good estimate because 58, if we round 58 to 60, because it's a free number, I know 60 times 5, cover up the 0, 6 times 5 is 30. If I put the 0 on the end, 300, 300 is quite far away from 2,743. So what I would probably do, you'd be rounding this one to sort of 2,700, 2700, or you could basically 0 go in there and an 8. In a perfect world, you'd roughly say it would be 500. And so we'll sort of make that 500, and let's double check. 5 times 5 is 25. and then we've put the 2 zeros on the end. 2,500. Much closer to 2,743 than 300. And again, you might do a little bit more estimating to get a bit closer, because roughly 2,500 taken away from this one here, the 243. So if I rounded 243 to a friendly number, not sure if you can see this down here, probably 250. How many times can 5 go into 250? If you know your multiplications, no worries. Too hard, so I'm going to cover that 0 up. 5 goes into 25 5 times, put the 0 on the end. So then I could probably say, where do we say, 500. Original estimate was 500. If I was going to be a bit more accurate, but without being super accurate, I could then say it's going to be roughly another 50. So an answer could either be 500 or 550. Roughly. It's not going to be perfect, but you want to justify, you want to explain and show your workings why you've come to either 550 or 500. All right. Easy really, eh? Again,